Okay, can we start, Rakesh? Can we start, Papia?
Yes, I
One
think
minute.
so. Yes.
Okay. Okay. Good evening, everybody. Welcome to today's Guru Talks session. Today's guest is Dr. Raja Kasilingam. Dr. Raja Kasilingam is a PhD from the University of Windsor, Master of Science from AIT, and he has more than 40 years of experience in uh, consulting, industrial management, industrial engineering, revenue management, pricing and scheduling, developing solutions for industrial management, specifically in the area of revenue management. He's also been a faculty, worked as professor in a couple of leading universities. And he's also held senior management positions in renowned companies like Sabre, CSX Transportation, American Airlines. So combined with a very strong academic background, he's contributed significantly to the field through pioneering research publications and teaching engagements. And his expertise spans across various industries, including aviation, logistics, and transportation, where he's led the uh, development of innovative systems and solutions. So currently, he's heading RTS, Revenue Technology Services, where they're developing some solutions for revenue management. So I'll pass it over to him. Welcome, Dr. Kasilingam, and you can just take over now.
Okay. Thank you so much for the introduction, Gopal. Good evening, good morning, and good afternoon. I know you're all from across the globe with different time zones. I want to first thank IIT Madras Alumni Association for giving me this great opportunity. Especially, I want to thank Gopal for roping me in. Gopal was one of my very early graduate students back in 1990-91 timeframe when I first started teaching at the University of Regina. Since then, I've moved across different industries and different companies across the globe, and finally settled down with the airline business. And I've been in this business for over 30 years in revenue management, scheduling, and pricing. The title of my presentation, as you all know, is Revolutionizing Revenue Management. Revolutionizing is a little bit of a stretch, but I will kind of take you through what has happened or what has transformed over the last 40 years, right? So I will look at it from my experience and expertise. My understanding is in the audience, we probably have some revenue management experts, and some of them could be novices. So my plan is to really take you through the origin of revenue management and then give you a future outlook. That's kind of what I'm planning to do. Okay. So the agenda is divided into 4 parts. First, I want to talk about the origin of revenue management. What are the roots, how it started, and when it started. Then I want to really level set because, as I said, the audience could be with different backgrounds and different levels of exposure to revenue management. So let me lay down the basic concepts of revenue management. After that, I will walk you through the evolution of revenue management over the last 30 years from my perspective. And then I also would kind of give you an idea in terms of, in my opinion, where do I think revenue management is heading. With that, let me get started with the origin of revenue management. If you really look at revenue management, it was pioneered in the airline industry. And American Airlines was the very first airline to introduce the concept of revenue management. It was then known as yield management. And the background goes like something like this. The deregulation of the airlines pricing happened sometime in late 70s, 1978. What deregulation did is it basically said you guys can charge whatever you want to, which essentially allowed low-cost carriers to enter into the market. And the case study goes something like this, where People's Express was one of the low-cost carriers, and because their cost base was really low, they were able to sell tickets at a very, very low prices in the markets where American Airlines was serving and selling at higher prices. So American was then faced with a dilemma: how do I really compete with People's Express without really losing a lot of money? So then CEO Robert Crandall really had a very creative idea. So he was thinking, lot of my costs are fixed and I have surplus seats. So I have surplus seats, I have marginal cost, and I have a competitor who is selling it at throwaway prices. So what do I do? So he came up with this brilliant idea. So if the capacity in a single leg for People's Express is 50 seats and American Airlines capacity is 100 seats, he said, let's just match or beat their prices on 50 seats. And then in the remaining 50 seats, we will come up with a creative idea. And that's when they talked about, how do I really differentiate a seat? Because a seat is a commodity. How do I really differentiate it? They came up with some perimeters around the seat. They said, if you book in advance 15 days before or 10 days before, the price is different. If you stay over a Saturday night, the price is different. If your round trip is 3 days versus 10 days, it's different. So they looked at advanced purchase restrictions, stay restrictions, Saturday night restriction, and then came up with different products and offered those products at a much higher price. So they were able to kill People's Express with lower prices on 50 seats, and then were able to make money on the remaining 50 seats by creating products that are really innovative. So that's really how revenue management started, which was then called as yield management. Again, if you have any questions or if you have any comments or feedback, you can just do it then and there, or you could also wait until the end of the presentation. It's entirely up to you guys. Yeah. So that's really the origin and roots of revenue management. Just to illustrate that, if you look at it, let's say if you have 100 seats or something, if you have a demand curve, ideally, if you have only one product, all you have to do is look at price elasticity and then fit the largest rectangle inside that price demand line, right? So if you have, assuming the line is a straight line, it could be a curve. But in a very simple term, if you have a straight line price demand curve, and then if you're having a single product, then you just try to fit the largest area inside that particular one. You have no other option. So when you do that, you're going to leave out a lot of area untouched in the curve, which is really lost profits or lost revenue. So what American did was essentially this. They now, instead of a seat being a seat, they created certain things around the seat and called them a different product. And now they're able to sell different products at different prices. So you maximize the area under the curve, which means you're maximizing your revenue from a given leg going from point A to point B. So this is how revenue management started, and this is the very basic principle of revenue management. Now, what are the basic requirements for revenue management to be successful, or when revenue management can actually be applied? Again, this is very, very rudimentary concept here. Things have changed over a period of time with low-cost carriers coming into picture and everything. So without going into a lot of discussions, there are 4 key things. One is the capacity is perishable. All that means is once the flight departs, you have no ability to sell the seat, which is common sense, but it's actually a big thing, a revelation at that point in time. Demand segmentation is possible and independent. If you cannot segment your demand, if people don't perceive a seat, one seat versus another seat as a different product, then you're not going to be able to apply revenue management. And the third thing is there should be an ability to make bookings in advance, and there should be a behavior from customers willing to actually book tickets in advance. And the last one is obviously price should not be regulated. If the government regulates everything, then you have very few opportunities to do it. You could still do revenue management given the price control, but the opportunities are very limited to do revenue management. So that's really some of the basics and origins of that. Now I want to touch upon the concepts of revenue management. My expertise has always been in the airline cargo revenue management, even though I have knowledge of passenger side, I have knowledge of cruise ferry revenue management, railroad, coach, hospitality, all of those things. I've done a lot of deep dive work in the area of air cargo revenue management. I've published a lot of articles. I've developed optimization and forecasting models personally myself several years ago, and I still continue to supervise some of my team members who work on improving this forecasting and optimization. So I'm going to focus on air cargo revenue management for the time being, and then maybe possibly for the rest of my presentation. When you really look at revenue management, there are 2 sides of the coin. One is supply side, the other one is demand side. All you're trying to do, I mean, this is common for every industry, right? You have supply, resources, you have demand. And you're trying to match your supply to demand in order to maximize your revenue or profit, whatever is your objective. That's exactly what you're doing in the air cargo revenue management. The first component is something called as capacity management. In capacity management, there are two things clearly. One is, what is the physical capacity available for sale? In air cargo, the physical capacity available for sale is not known in advance. Whereas on the passenger side, you know how many seats are in coach. Given an aircraft, you know how many seats are in coach, how many in business, how many in first class. But if someone tells you there's a 777 flying from Dubai to London, there is no way to know how much cargo capacity is available in advance. So you need to actually forecast cargo capacity, because there's a lot of things that have a higher boarding priority. Passengers board before cargo, passengers bag go before cargo, mail and then some parcel services go before cargo. So what you have to do is you have to look at the total payload of an airplane, and then you need to predict how many passengers will be on board and the corresponding weight, how much bag they will bring and the corresponding weight, and then anything else that goes before cargo. You have to subtract all from payload, and that gives you the capacity, physical capacity. Now, physical capacity by itself is not the supply side of it. You need to know what is the capacity available for sale. Because if you look at the passenger side, passengers may book, but some of them will cancel before actually coming to the gate, and some may not cancel and may not show up at the gate, which is what we call as a show of behavior. If there are 100 people who book, maybe only 80 people will show up, which means 20 people may cancel before departure or may not simply show up at the gate. So one is physical capacity, the other one is capacity available for sale. That's where overbooking comes into picture, and then I'll talk about it in the next couple of slides. So the first component is supply side, which includes physical capacity, forecasting show of behavior, and then completing overbooking. That's one component of it. When it comes to managing capacity, matching it against demand, there are two sides of the coin for air cargo. In the air cargo industry, your capacity is sold at different time levels. For example, there is something called as blocked space or allotments, which are negotiated between the airlines and freight forwarders over a period of 6 months in advance. So they could have, for example, DHL may buy space from American Airlines for the next 6 months for certain flights every Thursday or every Friday. These are called as blocked space or allotments. So the airlines have to really, this is called as a medium-term inventory control. The airlines have to look at the long-term demand forecast and then what is available from a supply side and decide which forwarders get how much space at what rates. That's the medium-term inventory control. The next one is the short-term inventory. So the medium-term inventory control is very similar to group bookings on the passenger side. Because if you're a corporate client, IBM or Accenture, you may block some tickets or spaces with American Airlines or Emirates for a certain time period, right? That's called as a group booking. Or that could be a leisure travel group, a vacation team group that could book some tickets. That's group travel. So the group travel is very similar to the medium-term allotment space on the cargo side. The next one is the short-term inventory control. This is when you're really looking at people just coming ad hoc and then trying to make the bookings. Again, concept is very similar. You forecast the demand and then you match it with supply at the network level, try to optimize, and then come up with the allocations. So these are the basic components of air cargo revenue management: capacity management, medium-term inventory control, short-term. Are there any questions on this before we move forward and go deep into each one of them? Okay, let me talk about overbooking. If you really look at it, I can't see it on the right side of my screen, but the flight has about 80 seats, which is on the orange side. And then if you look at the blue side, we have added about 20 seats. So the physical capacity available on this airplane is 80 seats, but the airline actually sells 100 seats. And the reason for that is they expect only 80% of the people who booked to show up. In other words, 20% of the people who booked will either cancel before departure or they will not show up at the gate. So when you do that, in a very simplistic math, all you're doing is taking your capacity of 80 and you're dividing it by 0.8, which gives you 100. In a deterministic situation, it's going to be 80 divided by 0.1, which gives you 100 seats, right? But the situation is not deterministic. It's a probabilistic behavior of a show, rate, and cancellation following different distributions. So it's a stochastic model, which is very similar to, some of the industrial engineers and mechanical engineers. You may have heard about something called as a newsboy problem. in the olden days, a newspaper vendor needs to go and buy X number of newspapers for that day to be sold. So if he buys 100 and if he can only sell 80, then essentially there's a 20% is like gone waste. But if he bought 100 and 120 people were requiring that, then he lost revenue on 20 newspapers, right? It's exactly the same. So what happens is, in this example, 80 seats is capacity, 100 seats is what you're trying to sell. And the predicted show up behavior is 80%. If more than 20% of the people cancel, then you result in spoilage because the flight goes with less than 80 seats. But if less than 20% of the people show up, then what happens is you have an oversale situation. I'm sure some of you may have experienced where you actually have a confirmed ticket, but the airline will tell you, sorry, we can't board you, right? That's the situation. So what this graph tells you, if you look at the overbooking level on the x-axis and the cost of overbooking on the y-axis, as you get aggressive on the overbooking, meaning you keep increasing your overbooking level, common sense will tell you, and anybody can intuitively understand, your offload cost will increase, right? So that's what we're looking at here. As you increase your overbooking level, your offload cost keeps going up. On the other hand, as you increase your overbooking level, your spoilage cost will keep coming down, right? Because the chances of people, it compensates, more than compensates for no-shows and cancellations. So what the models typically try to do is seek a trade-off between the spoilage cost and the offload cost, and then look at the sum of the minimum cost. That becomes the optimal overbooking level. Now, clearly, if you look at this, the cost is going to drive to a great extent which way you're going to shift, whether the overbooking level is going to be on this side or this side. So most airlines, what they will do is they will do something called as a service level constraint. On top of the optimal overbooking level, they'll make sure the optimal overbooking level does not exceed certain level of service level commitment that they want to give it to their customers. So this is, in a nutshell, what overbooking does. It's a trade-off between offloads and spoilage, and airlines always invariably overbook their seat capacity. And the reason for that is passengers inherently have a behavior of no-show at departure or cancel before departure. Okay, so that's the first component, which talks about the supply side of the equation. The next one is, once you know what's your supply side, and once you know what's your demand for different products, you're now matching the demand and supply through an optimization model. And the model will tell you how many seats to allocate to different demand groups or different products, right? So in inventory control, there are two methods. When I say inventory control, all it means is when a booking request comes in, how do you say accept or reject? That's what I mean by inventory control, right? So method one is you allocate seats for sale to different demand groups. And then when a request comes in, if space is available for the demand group, you say yes. If it's not available, you say no. That's method one. Method two is called as hurdle price. It is actually the maximum of bid price and a booking fare class. I'll come to this in the next couple of slides. So here what you do is you're controlling inventory based on a hurdle price. If the price is higher than hurdle price, you will accept the booking request. If the price is lower than hurdle price, you'll reject the booking request. So there are essentially two methods. There's also a hybrid method. You could combine these two. You could do a combination of hurdle price and allocations, right? But essentially there are two methods, and the third method is a hybrid. Now let's just look at how these methods typically work. If you look at the allocation-based inventory control, let's say the capacity is 100 and we have 3 products or 3 demand groups, and the optimization model tells you allocate 30 for high, 50 for medium, and 20 for low fare. Then the inventory control will be set as 100 for high, 70 for medium, and then 20 for low. And the reason for that is these are all forecasts. Whenever you say forecast, there are errors associated with that. So even though you forecasted the high fare demand as 30 or more, the real demand could be much higher than that. So you don't want to simply do an inventory control of 30, 50, and 20, because for some reason, if you have more than 30 from the high, you want to be able to sell that, right? So this is called as nested control, where you're nesting one into the other. First, you put all 50 for all 100 for the high fare, and then subtract the 30, that becomes for the second one, and you subtract the 50, that becomes for the last one. So this is the allocation-based inventory control. This is the bid price-based one. People who have done linear programming, they all know there is something called shadow price of the resource. In linear programming, all you're trying to do is you're trying to maximize something subject to capacity or resource availability, right? And then for every constraint, which is a resource availability, there is a dual price, which is called as the shadow prices. That's exactly what is bid price. When you solve an optimization model, bid price is the shadow price of the capacity constraints. And it's, in a sense, it's the value of capacity at a given time. So if you look at this one, assume there are two demand groups, and the demand for group 1 in red is 10 kg and the value is 2, and the demand for the second group is 20 kg and the value is $1.50, and your capacity is 25 kg. Let's assume, so it's 10 plus 20, there's a total of 30 demand, but your capacity is 25. So if you draw a line, you will see that the bid price is 1.5. And the reason for that is, your capacity is there, so you don't have any other demand available. So there's no reason to really sell anything less than 1.5 because there is sufficient demand available for at least $1.5, right? There's no reason to sell it. So the red fare class hurdle price, because even though the bid price is 1.5, when a request from this red demand comes, you don't want to sell it at 1.5 because the red demand fare is $2. So the hurdle price, which is actually the bid maximum of bid price and the fare, is 2. And the green fare class hurdle price will be the maximum of bid price and its fare class, which is 1.5. So this is one way of inventory control, right? Now let's assume that the capacity was not 25. Let's say it was 8 kg. Then the bid price is going to be $2 because you have sufficient demand of $2. So there's no reason to set the bid price at $1, right? So the red fare hurdle price will be maximum of hurdle price and bid price. I'm sorry, bid price and fare, which is 2. And the green is 2, maximum of 2 and 1, which is 2. So is this clear? So basically, as the booking happens, these rectangles will keep moving because if you really look at it, let's go back to the previous one. After, let's say, about 10 kg of this is booked, this line will move somewhere here to 15, right? Or if you sold 2 kg of this will move from 25 to 23. So this is a snapshot at a given point in time. Depending upon whether a booking materializes for the green or red, this capacity line is going to keep moving to the left, and the side dynamically changing based on which demand has materialized or not. I'm sorry, was that a question or? Oh, okay. Okay, so let me just summarize that with a linear programming example for some of the guys with OR background or industrial engineering background. When you look at airline revenue management, I will again touch upon this on the transformation that occurred. Typically, you would like to solve it at the network level. And the reason for that is, if you look at this, it's a very simple network. It has 2 legs, but there are 3 possible demand pairs. There could be a demand for AB, AC, and then BC, but there are only 2 legs. But in order to satisfy demand AC, you also need to have capacity in this and capacity in this. But to satisfy this, all you need is capacity here, all you need is capacity here, right? So the question is, when I'm looking at it, I have a look at it. If I have 1 unit of capacity available here and here, so do I take this and this, or do I take this? It really depends upon what is the revenue from here versus the sum of revenue from here. So if I take this information, let's say the demand for AB is 30 and the rate is 2, AC is 20 and 3.5, BC is this, and these are the capacities. I just solve it using an optimization solver, Cplex, Kurobi, whatever it may be, MATLAB. It comes up with results like this. It tells me what are the shadow prices of the constraints, AB and BC, and it tells me how much of OD demand for AB, AC, and BC have been allocated, right? So the model gives me bid price, and I can use the bid price to get the hurdle prices, and that becomes the control values to really decide whether to accept or reject a shipment. So this is really, going back to this is really basics of revenue management. One side is supply side. which is physical capacity and overbooking. And the second side is more in terms of how do I really accept or reject a booking request, right? Based on either allocation or hurdle prices or a combination of both. That's really what is happening. Again, if there are any comments or questions, I can stop, or if not, I will move forward with my next section. I think we're doing well, reasonably on time. I'm going to look at it from the last 30 years, 30 to 40 years actually, and more so from an air cargo revenue management, because on the passenger side, there's been tons of advancements that have taken place, right? Air cargo revenue management kind of lags behind the passenger revenue management in a number of ways, but it also is quite different and complicated than the passenger revenue management in a number of different ways. I'll talk about that as we go through this. Okay. So when I talk about evolution, I thought I will walk you guys through evolution from different angles, different perspectives, and different aspects. So the first one I want to really talk about is from what is our objective of revenue management? Back in the early 80s, the objective of revenue management, it was actually called as yield management, was to improve yield per seat. So it was called as yield management, right? You're really focused on dollar per kilo or dollar per seat. Then they moved towards revenue for a given complete airplane, a particular leg. So it's $1 per airplane, or that's what you're looking at. Then they realized maximizing revenue is not the real goal. We have to actually maximize margin or profit, because your cost could be different for different products and cost could be different for different legs. So the transition over the last 3 years, even though some of these things may look like really common sense, and it's always hindsight is 2020, right? We always think like, why didn't we do this before? So, but that's kind of a very simple thing, but this is how it kind of evolved, at least from a money or dollar perspective. Next, I want to look at it from a business standpoint. My first job at American Airlines was really to focus on capacity. A lot of the airlines in the cargo industry did not really go with capacity, overbooking, allotment, and booking all at once, right? It all happened over a number of years. So the very first thing they attacked was getting a grip on capacity, because cargo capacity is unknown. So capacity was the main focus of airlines on the cargo side for over 10 years, right? And then came allotment, and then came booking management, and now it's the whole suite that includes capacity, allotment, and booking management. That's completely managed by revenue management. So this is an evolution that happened. I was fortunate enough to be involved in every one of the phases. In fact, my first project was with American Airlines on capacity. My second was with Cathay Pacific on allotment. And then subsequently, we did something similar for another airline, Continental, on the booking management. In terms of the inventory control, the early days of yield management, revenue management purely was working based on capacity. Then they moved to nested controls, virtual nesting, because not leg-based, it's O&D based. So you have to consider the O&D allocations versus local allocations. Then came hurdle price and bid price. And today, we are really talking about dynamic pricing, right? It's real time. It keeps changing based on booking behavior, based on number of different parameters. So that's how the transition happened in terms of inventory control. If you look at it from the various coverages, like for example, what aspects are included in revenue management? Initially in revenue management, it was purely financial, purely capacity and demand. Then they started including operational aspects of revenue management. For example, it's not enough for, one of the biggest differences between airline passenger and airline cargo is three-dimensional, because in passenger side, capacity is a single dimension, a seat is a seat. On the cargo side, you have weight, volume, and container, right? So if it's a narrow body, you have weight and volume, and the flight can be weight or volume constrained, depending upon the density of the freight that's being booked. If it's a wide body, you have weight, volume, and positions, right? So when you talk about operational constraints, it's about, do I have enough time to actually load cargo after unloading cargo, unloading passenger bags, unloading passengers? So there is a ground time constraint. Then you also look at things like, how do they all fit together when I put them into a container? You have to think about that too, because you cannot randomly book everything just based on revenue. and then you're finally trying to pack it on a pallet or a container, then it doesn't really go well, and you have to reject something and bring it back to the terminal, right? So in that sense, the three-dimensional complexity adds a lot more uncertainty and stochastic nature to the air cargo revenue management. After that, people started focusing on customer value. I will give a small example on this. Again, it's a very simplistic example. It's a lot more complex than what I'm presenting here. All you're doing here is you pick a few attributes that are really important in defining the value of a customer. So in the airline cargo industry, you might say that the revenue that's brought by the customer is one of the important factors. Density of cargo is important because it plays a major role in filling weight and volume capacity. Try to get the best use of it. Then the market and wallet share. How much this customer is giving me in that market, and how much of this customer's share is in the total when compared to the other customers. So you look at the market and wallet share, and then the usage or utilization is if they tell you this is how much they will bring, how much they actually bring, right? So this is just an example of 4 attributes. There could be 10 or 20 attributes. And then all you have to do is have them all in a scale of 0 to 10, and then apply a weightage for each one of them. And we have come up with some sophisticated methods, analytic hierarchy process, and then some other methods using artificial intelligence to really assign weights rather than manually assigning. So you take the 4 different attributes and then weight them based on whatever is appropriate weights, and then you come up with the customer value. And the next one is shipment priority. Shipment priority kicks in when you have more shipments tendered at the dock than what you can actually load in the aircraft. Now you are faced with a challenge, which ones actually get loaded and which ones are left behind. So there needs to be some kind of a methodology to decide which shipments go first, which shipments go second, third, and that's what we call a shipment priority. So these are some of the peripheral aspects, like the operational side and shipment priority side. They're peripheral aspects that actually are considered as part of revenue management. And then finally, business rules is one thing. And there could be different business rules. If this is the case, do this. If this is the case, do that. So all of those things play into it as well. Next, I would like to talk about the data and models side of the evolution. Again, in the good old days, exponential smoothing was the way to go, moving average exponential smoothing. Very primitive, but you'll be surprised. A lot of the Box-Jenkins autoregressive moving models never ever did better than simple exponential smoothing models. I mean, forecasting gurus might be surprised about this, but I've personally done a lot of testing on the cargo side. Passenger side is a different story. And the simple reason is cargo demand is very lumpy, right? It is not like very uniform and things like that. And the lumpy nature of the demand does not really yield very well to a lot of sophisticated models. So after that, very quickly, people started using historical data and booking data. So now we are looking at past data and what is happening at this point in time. Then it's real-time data, meaning like daily changes to cancellation. Everything is taken into account in terms of feeding into it. And finally, then we are looking at AI/ML models. That's really what we are looking at. Last 3 years or so, we have actually established a small research and development team, which really focuses on deep learning techniques, KNN models, and a number of other things. And we are trying to see, and we have actually seen some real good improvements in terms of forecast errors or forecast accuracies by using some of the AI/ML models. Lastly, in terms of technology, obviously, I remember I was using JCL and focused language back in late 80s and early 90s, and we did the programming based on that. Then came the thick client, Unisys, and then came web, and now finally it's all hosted and cloud solutions. Right? That's from a technology standpoint. So this is how I would probably describe the transformation that took place along the different dimensions of revenue management. So given that, how do I see, I'm sure different people could see this differently, how do I see where we are heading towards in the revenue management space, at least on the air cargo side? I think the major drivers that are deciding or determining which way we are heading, I would probably put them into 5 categories. I mean, again, people can put them in different categories and different reasons. the availability and quality of data. Again, as it may be as simple as it sounds, you'll be surprised that even today, how there are missing data, there's poor quality of data, and there is so much work that needs to be done to clean up data and ensure data is actually input on time or collected on time. So there's a lot of work that's still happening, but we have come a long way compared to 25 years ago, right? So once you know that data is available and the quality of data is really good, that actually changes the ballgame. Now you're able to now apply sophisticated methods, you don't have to really work on primitive ones. So that's going to be a major driver. And the next one is the big data, the ability to store and process large amount of data, both quantitative and qualitative data. That's going to drive the revenue management in a different directions in the future. Predictive AI has come a long way. I know AI is a buzzword and a lot of people get on the bandwagon. I have a different opinion on some of these things. But at the same time, I will never downplay the impact and effectiveness of AI on revenue management, because we have personally seen in our own research, we have actually started implementing generative AI models in our products to assist the users. And predictive AI has always been part of our research to move the dial in forecasting and optimization. And finally, the cloud-based solutions, right? The technology architecture and cloud-based solutions today and 20 years from today is going to be completely different, right? And again, I'm not an expert in that area, but that's going to also decide how you're going to architect your solution, how you're going to create the usability of the solution and implementation. So some are in the design side, some are on the usability side, some are actually in terms of the implementation side. So what are the different things or attributes I'm thinking will be part of the future of revenue management? Clearly, everyone talks about artificial intelligence and machine learning in almost every industry we can look at, right? The other one is, rather than sticking to certain models in the solution, how about auto-picking forecasting models on the run, on the fly, right? Maybe today you'll use this model, tomorrow it could be different based on that. Or for one market, use this model, you use a different model for another market, right? It's already in the works in some of our solutions, but I don't think it's very sophisticated today in terms of a daily basis, right? Embedding customer value is going to be very critical. Business tools, I mentioned about it. Dynamic pricing aided by bid prices. Revenue management pricing has always been two different disciplines in most airlines and even in the air cargo department. I think the line is kind of becoming a little bit hazy now. It's kind of merging slowly. And I'll talk about that in a little bit. So that's one aspect that's going to drive the future of revenue management. The next one is more on the booking evaluations and options. On the passenger side, we see it already, right? When you actually go to Expedia or any portal, or go to American Airlines portal, you type in where you want to go, it just gives you a bunch of options. Non-stop, one-stop, two-stop, everything. You go to Google Flights basically gives you a grid where you can actually see your onward flight and return flight. It gives you all possible combinations and the fares, right? That's not where we are today yet on the air cargo side. Some airlines have reached that point. Not every airline has done that or accomplished that. And then finally, the cloud-based solution, whatever that means, will keep changing almost every year. So this is how I look at the future of revenue management. So I believe this is my last slide, if I'm right. Dynamic pricing, in my view, is taking some of the inputs of revenue management, including the concepts of price elasticity, willingness to pay, probability of acceptance, customer value, and then throwing one number, right? When a customer comes and asks, you look at all of these things and then say, hey, here's the price. And it works both ways. A customer can come and say, hey, I have something to ship, and this is what I'm willing to offer. Will you take it or not? That's one scenario. The other one is the customer will come and tell you, this is what I'm trying to ship. Tell me what's your offer price. And then the airline offers it. The customer either says yes or no. So the customer names the price, and then the airline says yes or no. Or the customer asks for a price, and then the airline tells, this is a price, you want to take it or not. And the way it works is, it's a very simple concept. All you're looking at is, you look at your bid price, you look at what is the contract price with the customer, you look at what is the floor price of the cost, or a target price, which is the margin plus the floor price. You take the maximum of that, the upper line, you take the minimum of that, and then you try to run a price elasticity analysis based on willingness, probability of acceptance, and then say, hey, here's the price. That's kind of how we look at the future, but the future is already here, in my opinion. At least some of the airlines we know of on the cargo side have already started using this methodology. A lot more sophisticated than this, but fundamentally it looks something like this. With that, I would like to probably stop with my presentation, and I think I'm probably done 5 minutes ahead of time.
Dr. Kasilingam, there are some questions for you on the chat box. You can just answer them.
Okay. Okay, so I think the first question is how easy it is to get access to historical data. Is that right?
Yeah.
Okay, got it. Okay. Well, when you look at historical data, there are a number of different types of historical data. Let's just take the example of air cargo industry. The first piece of data is really airable data, which is similar to the PNR data on the passenger side. All it means is every time you ship something, there's a bill of lading, and then that's called as the airable data, right? And today, it used to be a paper airable, now it's e-airable, and most of them are completely electronic. So that data is available, so it's very easy to capture. The question is, do people have accurate weight and volume information? Weight information is always accurate. Volume information may not be accurate. And they may not put the right commodity code, which means proxy density calculation is going to be difficult. So the answer to the question is historical data is easy, similar to even on the payload side. If you want to know, after the flight departs, they know what was the payload, how much was the passenger weight, bag weight, everything is recorded on the load sheet, right? So that information is available as well. And based on our experience in the last 30 years, the payload data has been reasonably accurate with 90% of the airlines. So the first question, I would say it's easy to get them, and for most part, they're very good, very reliable. What is the reliability of Gen A models into, okay. I think the reliability of Gen AI, we all know, is as good as the information that's fed into it, right? So if it's having limited information, then it's going to be based on that. If it has extensive, a lot of depth in the amount of information provided, then it's going to be a lot better. So I would say the reliability is directly related to the amount of information that's being fed to train the Gen AI models. I don't know whether there's any technology-related challenges that could cause reliability changes. It's more in terms of the amount of content and the training that's been done. That's my opinion. Again, I'm not a great expert in AI, but based on whatever we have done, limited testing, that would be my response. Are there any other industries that have adopted pricing criteria based on? Oh yeah, I mean, tons of industries. I think from airline, it moved to railroad, it went to hotel industry, car rental industry, cruise industry, cruise ferries. So a number of industries, wherever you have a perishable product, bookings are made in advance, demand can be segmented into groups. There will be revenue management, right? There are opportunities to implement revenue management. So that will be my response to that. From a consumer user view, say for airline tickets, how can we beat the system to get the fixed price? Okay, if you have an answer, I would probably do it because I try to book my tickets. I don't think I've been able to, but one thing I can tell you is there are certain adjustments some airlines do on certain days of the week, right? My wife has told me something about this. She said, when you're looking for tickets to go to India, look at it on a Tuesday evening. I don't know, maybe her friends told that's how it works. And the other thing is, if you try it in one device, next time try it in a different device, because they know from which device you accessed, and no matter how many times you keep checking, your price will never go down. This is, again, my experience, right? And never is too strong a word, but very unlikely to go down, right? So I think from a customer point of view, if you're a business customer, the way to beat that is become a high value customer. That's one way to really get better pricing. But as a B2C customer, I really don't know how you can beat the system, because the system is very smart and it looks at a lot of your behavior in terms of, what you're doing now, where you're searching, and it looks at everything, right? I have a feeling, I mean, if you're looking at British Airways and you try to go to American Airlines, there's a good chance, if there are back-end communication, they will know. So it's going to be hard to beat, but if you found a way to do it, I would love to have it there.
Any other questions? You can just unmute yourself and just ask Dr. Kasilingam. Any questions for Dr. Kasilingam? Kindly you can unmute yourself and you can ask. Okay, I think there are no more questions as of now. There's
Oh, I think.
Yeah. So there's just okay. So there's just one question, like before there used to be a lot of simulation models. Now I think there's a lot of machine learning models that have just that are coming into the picture. So what's your opinion about these two different types of models, simulation versus machine learning models?
Okay. Simulation models in revenue management were never used in the product. They were used to test the models, the efficiency and effectiveness of the solutions, right? In a software or a product that's installed at different airlines, simulations models were not used. They were, right from the beginning, I mean, if you look at the airline revenue management, there are two aspects. One is forecasting is the key, because forecasting supply, forecasting demand. And there's been studies done, like for every percentage improvement in forecasting, it translates into X percentage improvement in your revenue, right? Forecasting. The next one is optimization. Simulation comes when you want to really evaluate how good the forecast errors or optimization models are performing, right? So all the models we have used up until probably 5 years ago, they've always been regression models or auto regression models and Bayesian models and things like that. In the past 5 years, some of the AA models have picked up. A lot of the vendors have incorporated some of them, but I would still be very hesitant to categorically tell you that AA models, at least in the air cargo industry, have shown consistent improvement over a period of time, right? Because we ourselves have tested some. It has improved in some areas. It has not improved in some other areas, right? So I'm not sure if I answered your question, but it's been a long journey, but it's only in the last 5 years people have even started looking into those models. But I think it's getting into high gear. 2024, every conference you go to, it's always about AML, right? So it's getting into very high gear very quickly.
Yeah. Okay. Any more questions, please? We'll just wait for a couple of minutes. If any of you have any questions, you can just post it on the chat box, or you can unmute yourself.
Yeah, I also would like to know, I mean, I'm sure there are some experts here, and I've never, I always thought that I learn every time I meet a person or every time I do a session, right? There's always somebody who knows more than you. So if you have anything that you feel like is on the left side of the thing, and if you want to point it, I would be gladly, interested in knowing about it. Any constructive criticism, feedback, please feel free to. There's always a path to learn.
Hi, I have a question. So, have you seen any cases like this much detailed revenue management is actually happening in two industries? One is cloud kitchen and one is FMCG. Do you know any cases that this is happening?
Okay, is that the same question on the screen I see, the KPIs, or no?
No.
Okay, can you please repeat the question? I'm unable to hear properly.
Yeah, I was asking two different industries. Okay, one is FMCG, like an FMCG product, right? Like say Nestle, and second is a cloud kitchens like Zomato or Swiggy. So I want to know whether these kind of airline, this much detailed revenue management, are the industries also looking at in the future, or have you seen that?
Okay, As I mentioned, anytime you have perishable capacity, you have resources that are demand is competing for, you can apply revenue management, which means you can do it in automobile industry. Because if you have a machine tool, if you have a cellular manufacturing system with a CNC machine 1, 2, 3, after that 8 hours is over, that capacity is perished, right? The concept of perishable capacity exists everywhere, not just airline, right? When the clock is up, capacity is gone. If you didn't use the CNC machine 1, you just lost the capacity, right? So when you have different machine tools, and there are different products that have to go through different sequence on the machine tools, and they are sold at different prices and costs, you apply revenue management, right? It's a linear programming or a stochastic nonlinear programming model where you maximize an objective of revenue or profit subject to resource constraints. So to answer your question, it can be applied in many. The only thing is it's not true revenue management because you're not taking, unless it's a job shop where you have orders coming in and orders can be processed several days. So the answer to your question is yes, but whether it's applied or not really. People don't look at it that way. They look at it more from a production planning model, but less from a revenue management optics. But it could be. You just formulate the problem in such a way, the orders are placed at certain time for certain days, you could just do it, yeah.
Yeah,
Yeah.
thank you.
Yeah.
Okay,
There's
what are
one
the
more
KPIs?
question.
I'm sorry, yeah, go ahead, yeah.
Yeah, there's one more question. I was just telling you this.
Yeah, I see what are the KPIs do you suggest to track the effectiveness of yield management strategies? Well, this is always a contention in the industry. There are two things, right? We actually have some built-in models that assess the value of overbooking and the value of optimization. So what it's called as revenue opportunity model. If you didn't have any revenue management, you're following first come, first served. When a request comes in, you just accept. Next request comes in, accept until your capacity is completely depleted, right? That's the basis, first come, first served. The next thing is, if you have a perfect knowledge of demand, then it's a deterministic problem. You can just simply solve an optimization problem, a linear programming, and it'll tell you this is the maximum revenue I can accomplish. So the base is first come, first serve, no revenue management strategy. Anything that as it comes, you just accept it. Next one is you had perfect knowledge of demand, and this is your revenue from an optimization model. So this is the revenue opportunity. And what you look at is based on your models and methods, how much of revenue opportunity you actually captured. That's where when Gopal mentioned simulation, you rerun the booking process and now see, based on the controls you put in place, how much of this opportunity you captured. So that's one KPI. Similarly, for overbooking, you can do something exactly the same. All these things are perfect rerun of what just happened, right? You simulate after the fact. If I had this controls versus this control, what could have happened? So the KPI is really what's your margin, total margin. That's really your KPI. A KPI can be load factor, but it's a misleading load factor information because you can make more money with less load factor, right? Because it all depends on the mix of freight or mix of passengers you're carrying. So I would say there's one KPI, which is really how much really the KPI people look for. But there are a lot of other KPIs in terms of how it increases productivity, how much you can reduce manpower. All those things are side benefits, but the main goal is to make money. That's a goal, right? Make profits. Okay.
So
Any other
we'll just
questions?
keep it open. Any other questions, you can please ask Dr. Kasilingam. You can unmute yourself or put it in the chat box. We'll just keep the session open for another 5 minutes.
Okay.
Yeah. Any industrial engineers or PhDs in industrial engineering, you can just, or some of the younger people who have joined, you can just post your questions.
Yeah, I would actually like that because, I'm about to retire on my way out, and I'm sure the younger blood probably knows a lot more about AI, ML, and you're all like, research and everything. So any opinions you have or any thoughts you have, please feel free to share.
Hi, Raja sir, I'm Krishna here. Can you show us the second slide again?
Okay. Oops, sorry.
Because I think that's the most relevant, industry not being regulated.
Yep, right here. Yeah. Mhm.
No, there was a slide where you mentioned there are 4 points under which, this whole revenue management could work well.
Oh, okay. Sorry.
Maybe the number's wrong from my side, but yeah, okay.
Mhm.
Yeah, so this is the situation in which I think I could think of a revenue management based on certain timelines or, certain things
Right.
being closed, right? Yeah.
Mhm.
Okay.
Yeah. I mean, there's one point I've not listed here, where you obviously you want demand to exceed supply, right? Because if you have excess capacity, there's no real need to say yes or cherry pick. You just take them all, right? But a lot of the airlines will argue that, hey, I don't have enough demand in certain legs. But the key is, as long as you have demand in certain parts of your network, revenue management will work. Because when you look at the O&D level, even if you have excess demand in some parts of your network, you still do revenue management. Unless every single leg has excess capacity, you will have an opportunity for revenue management. I didn't put that in because it's a contentious argument sometimes. People don't grasp the nature of O&D versus leg. It's such an important thing. A lot of people think it's a proration revenue. It's actually not proration. When you're taking, like the simple example I gave you guys here, if you all have patience, if you look at this, when you solve this problem, linear programming does not prorate the A to C revenue to A, B, and BC by the distance or anything. It does not. It simply looks at it based on shadow prices, which is way different than prorating based on distance or anything else. A lot of the people in revenue management have a total misunderstanding when it comes to O&D revenue management. They think proration will work when you do O&D. Proration will not work. In fact, to explain this, I have about 10 slides that can go into detail why O&D versus leg is so important in revenue management in an airline network. And interestingly, the cargo industry was the very first one to implement O&D revenue management. Most of the times, the pioneers are passenger side, but the very first O&D revenue management was on the cargo side, because cargo by nature yields to O&D base, because cargo wants to go from A to C, doesn't care how it gets there, right? Whereas passengers may choose, hey, I want to go through Boston instead of New York. New York airport is terrible, so I'll go through Boston. Or, I would pick Doha versus Abu Dhabi, because I have to do custom clearance to US and Abu Dhabi, which is a hassle, right? Whereas cargo doesn't complain. It just, as long as you're able to meet the timeline when it needs to be there, you can put it on any flight and any path. So the routings play a major role in cargo, whereas even though it does play a good role, but people don't look at it seriously. On the cargo side, we take into account the routing aspects very seriously, because you have multiple routes. Just imagine if you have multiple hubs, then you have multiple flights between the hubs. There are so many route possibilities to still meet the same time definiteness of the product. And then there is embargoes, whether the station can handle, do they have cooling stations? So there are a lot of things you need to take into account when you fly cargo, through this station versus this station. Is the terminal going to be open at this time when the flight arrives? Is the storage facility available? I know you can go on and on. There's so much involved in this, which I didn't really touch upon. Any more questions or?
There's one more question. Jamal has asked a question.
Oh, how do we handle unexpected disruptions such as weather events? Sure, yeah. There is something called as shipment reaccommodation on the cargo side, meaning for whatever reason, a flight was canceled where this shipment was booked, you have to now reroute it, right? So there are real-time disruption models, both on the cargo side and the passenger side. So they are not really revenue management. They are operational models. They look at the snapshot at that point in time, and then they decide, given where the passengers are at different terminals, where the flights are at different places, what is the best way to route these people. So there are models that look at customer value. There are models that look at how much revenue this passenger gives, how much, they look at a number of different factors, leisure versus business, and then decide which passengers do I bump, which passengers do I put on the next immediate flight or a roundabout flight. So yeah, it's not part of revenue management. It is an operational solution, and a lot of airlines have come a long way in doing that. So there are reaccommodation models that are available that take into account all this information. I mean, I'm not sure how many of you have experienced it. Let's say you're booked on a flight, and for some reason one of the legs is canceled or delayed. At least, I'm with American Airlines and Executive Platinum. I get a message right away, and I get my rebooking right away. I get a message that my flight is delayed or canceled. Next second or minute, I get another one saying that, hey, you've been automatically rebooked on this. Now, if I don't like it, I can always pick up the phone and call the agent and then say, this is not something I'm comfortable with. Is there a way you can put me in a different one? Does that answer the question? It's not really part of revenue management, but it's getting very sophisticated these days.
Yeah. Okay. I think there were a lot of questions asked, and Dr. Kasilingam patiently answered all the questions. And thank you, Dr. Kasilingam. It was a very, very informative talk. You are a pioneer in industrial engineering, industrial management, and you've done a lot of cutting-edge work relevant work in many industries, and your solutions and your products are being used everywhere. So it's very, very informative. And especially if there are younger people, PhDs, who have joined on the call, I just encourage you to take up the study of industrial systems engineering or industrial management. As you can see, it's very, very interesting, and you can contribute very actively. And thank you once again, Dr. Kasilingam. Very, very informative talk on behalf of the alumni. And can I just ask Rakesh to propose a vote of thanks, please, so that we can just close.
Before that, I just want to add one little thing along the lines of you mentioned, Gopal. My kids always ask me, do you ever apply what you studied? And every time they study something, linear algebra or calculus, they are always like, why am I supposed to study? And I tell them, even today, I think I chose a field where I could apply everything I learned right from the day I graduated up until today. I think I'm very happy that I was in industrial engineering, because industrial engineering is about making things better. And there is always way, and I've applied optimization, forecasting, everything I learned is applied every single day up until today. So.
Yes, amazing. And Rakesh?
Yes, sir. I mean, today Papia will give the vote of thanks, actually.
Okay.
Papia, please go.
Thank you, sir. Thank you, Kasilingam sir, for this wonderful session. We are very delighted to have you here with us. And we'll share these YouTube links with all our alumni. And whatever the feedback we'll get or any questions, we'll consolidate and send it for the answer. Thank you once again, sir.
Absolutely. Thank you so much for your patience and listening to my 45 minutes. Feel free to send the questions. I'll definitely respond to all.
Sure.
We'll appreciate the opportunity again. Okay. Thank you. You all have a good rest of the day, evening, and afternoons. Yeah. Bye. Take care.
Thank you, everybody. Thank you.
Thank you.
Thank you so much, sir, and have a nice day. And thank you.
Bye now.